In this video, we will look at a lesser-known experimental project known as the F-18 HARV. Would head a program known as the High Angle of Attack Technology Program, or HATP. Langley would work alongside several other NASA research centers to conceptualize and produce technology, and it had no AOA restrictions at normal center of gravity positions. Thus, it was a good candidate for the project. It would be named the High Alpha Research Vehicle, or HARV. Researchers decided on a three-phase program, with each phase focusing on new areas of improvement by engineers. It lacked over 400 parts and had little information on its existing wiring system. Thus, researchers had to find substitute parts, take out all wires from the aircraft, and then rewire it. And monitoring equipment was set up both on board and on the ground. Videotape and film cameras were set up to closely monitor airflow using the tracer smoke systems, which released smoke just in front of the leading edge of the wind tunnel testing. This phase would look further into the dynamics of high AOA performance and integrate thrust vectoring. By July 1991, the HARV was ready for testing. This system allowed increased agility at medium and high AOA up to 70 degrees. The system carried the added benefit of prolonged flight at this AOA, allowing more data to be collected. To assist the test pilots, a new flight control system was installed, known as the PACE 1750A, coded with new flight control laws. For takeoff, landings, and in the case of emergencies, the pilots could also switch back to the standard F-18 flight control system. This second phase, which consisted of 193 flights, engine intakes during these high AOA maneuvers, measured 4 feet long by 6 inches wide, would move depending on angle of attack. In standard flight, they sat flush, whilst at higher AOAs, they would extend to interact with the vortices. The integration of these strakes would allow the pilot to switch between 3 flight modes. The first would use thrust vectoring alone. The second used thrust vectoring for pitch and strakes for lateral control. The third used strakes for lateral control and vectoring for longitudinal control. After 109 flights, Phase 3 would come to an end in September 1996. The program had increased the parameters of what was possible, giving important insight into the nature of high AOA performance. In September 1996. It now sits on display in the Virginia Air and Space Research Center in Hampton, Virginia.